What's up, everybody? Here is a review, a quick review. I'm going to zip through all these problems, and hopefully you guys know you can skip through and see which ones you got wrong and maybe get some extra help before the test. All right. Remember, there are 4 different kind of types of situations when we're dealing with the radical symbol, right? And then there's that last one where we have the negative on the inside. Okay, this is just looking for a positive square root. This is just looking for the negative square root. This is the positive and negative square root. And this is no real solution, right? Because you can't find the square root of a negative number. All right, so that's just asking for the positive square root, so it's 6. And we're moving on to this one. Now, this is asking for the negative square root. So we want to get rid of those right off the bat. And then how do we find the square root of fraction? We take the square root of each individual part, the numerator and denominator, and we get 14 over 9. So 14 ninths, where is it? Negative 14 ninths, bingo. All right, again, it's asking for the negative square root. So the square root of 144 is 12. 12 times 12 equals 144, but also negative 12 times negative 12, because a negative times a negative equals a positive, is the answer as well. So let's go zipping through, rewind, or go back if you have trouble. Now, this is asking for the cube root. So what number times itself 3 times will give you 27? And what could be used as a factor 3 times to get you 64? That's going to be 3/4. And there's only one answer when we're talking about cube roots, where there could be 2 answers when you're talking about square roots. All right, in this case, you want the positive and the negative answer to the square root of 225. Well, we know the square root of 225 is, without the decimal, 2.25 is here, but we know that 15 times 15 gives us actually 225 without the decimal. So we want it to be 2.25. So how are we going to adjust the 15s to get us 2 decimal places? Well, if we give each of them 1 decimal place, right, 1 decimal place each, then the answer is going to have 2 decimal places. All right. Here we have another example similar. This is asking for just the negative. Oops, sorry, I didn't give the answer up here. It does ask for the positive and negative answer, so we'll do that. Number 6, it's asking just for the negative answer. We know that 7 times 7 equals 49, but this is asking for 0.49, which has 2 decimal places. So when we multiply, we're going to have to give that a decimal place each so that the answer will have 2 decimal places. So that is just the negative version there, 0.7. All right, now this is the trickiest one of the trickiest ones on the page, because it asks for perimeter, but it only gives you the area. Well, how do we do that? We don't have a formula that has a big A and a little and a perimeter symbol in it. We only know how to get the side length from the area, right? Because we know that the area of a square equals side squared. Okay, so then we can substitute in for big A, 144 equals S squared, and that will give us square root, right? It gives us 12S. Now it also gives us negative 12, but remember, we're talking about squares here, so we don't have negative lengths here. So we just care about the 12. All right, so now we know the side is 12. Does that help us with the perimeter? Well, all the way around would be, right? Perimeter is the length around the outside of a shape, so 12 plus 12 plus 12 plus 12, or 12 times 4, which is this formula they gave you. All right, the side length times 4, so we're going to have 48. 48 inches is your answer. So that was there's like a step. Before you could figure out the perimeter by doing 4 times the side, you actually had to find what the side was, and that's what we used that area formula for. All right, continue. Okay, estimate to the nearest integer. If we use our tool and we spot that the square root of 36 and the square root of 49 gives us 6 and 7, right? Square root of 38 would be right in between, except more towards the square root of 36, because it's only 2 away from that, but it's 11 away from 49, so it's going to be closer to 6. The answer would be, so 53. Now what square roots is, what perfect squares is that close to? That would be 49, would be 7 times 7, and 8 times 8 would be, 64. So it's closer to the square root of 49, which is 7, than it would be to the square root of 64. So that's going to be 7. All right, keep it moving. Ooh, this one I'm pretty sure I know, because 99 is really close to 100. So the closest integer answer is going to be 10. Okay, I could put the 81 and the 99 and the 100 on my number line, right? Oops, I don't put that one on the number line. Silly. Got ahead of myself. All right, right, square root of 99 would be way up here, close to that, which is 10. Oops, I did that last time. I keep doing square root of 81 is, did it again, is 8, but it's really 9. Okay, weird. All right, keep it going, keep it going. All right, cube root, that's telling me something times something times something equals 1,000. And this something all have to be the same exact number. So what could get you 1,000? How about 10 times 10 times 10? Awesome, the answer is 10, yay. Keep going, estimate the cube root of 30. So that means we need to know our closest cube roots. So cube root of 27 would be 3. Cube root of 64 would be 4. So cube root of 30 is going to be somewhere in there, and much more close to the answer that you get for cube root of 27. So our closest whole number is going to be 3. Excuse me. All right, keeping it rolling here. Order from least to greatest. Well, cube root of 61, that's kind of close to this cube root of 64. So, but it's less than, right? So I'm thinking in my head, I'm thinking that's like a little less than, what's the square root of 64? Square root of 64 is 8. Okay, so this square root of 61 must be a little less than 8. And then we have the square root of 71, which is kind of, it's bigger than the square root of 64, but smaller than the square root of 81. So it's in between 8 and 9, but a little bit closer to that guy. So it's kind of like 8.5-ish, maybe, or 8.4 or something like that. But it doesn't matter because we have 8. So this is a little more than 8. Okay, so a little less than 8, a little more than 8. So, right, so we have 8. So 8, we have a number a little less than 8, which is 61. And we have a number a little more than 8, which is square root of 71. And then we have 10, which is way greater than all of them. Okay, so I just kind of ballpark that. You can also use your number line cheat sheets and just, or your tool that we wrote in our notes. Okay? Where is it? Oh, it's A. There we go. All right. Oh, and sorry, this should have been a 3 right there, but it doesn't affect it that much. Okay. Name all the sets to which, excuse me, the real number belongs. All right, -9. And what do we have? We have natural numbers. We got whole numbers, we got integers, and we got rational numbers, and then, the other side of that is irrational. Okay, we look at -9, and it's, remember, natural numbers cannot, no negatives, and no decimals. So no negatives, that cancels it out. It cannot be that. Whole number, no decimals, no negatives, right? Oh, and this one too, natural number, no zero. That's the only difference between natural and whole is the zero. So this would be integers just have to have no decimal. So this has no decimal, so it's not whole, but it is an integer. And rational, can it be written as a fraction? Sure it can be. Look, -9/1. So rational. All right? Rational and integer. Boom. Keep it moving, keep it moving. Okay, we're going to classify this guy. All right, when I square root that, it gets me 12. All right, well, let's look. Is it natural? Sure, it doesn't have a negative. It doesn't have a decimal. It's just your regular counting number. So that says, yes, it's natural. Yes, it's whole. Is it an integer? Yes, it's an integer because there's no decimal there. And rational, yes, because I can make it into a fraction by putting it over 1. So we got, they don't have natural here, but we had to go with D because they don't have another option. All right, now we're listing a number. Name a number that is not a whole number. Okay, not a whole number, so just give it a decimal, or make it a negative. So -7 would be a good idea. So these are the not whole numbers. 1.3 would be one. Square root of 10 would be not a whole number. All right. Decimals and negatives throw it off, so it's not a whole number. A number that is not an integer. Okay, so decimals would throw us off here. So -1.2, 5.7, any fractions that don't simplify, 2/3, and also any irrational number like square root of 7. And next, a number that is not a rational number, so we need irrational. So that's any of our square roots that aren't of perfect squares. All right, square root of 16, right, because that equals 4, so that would be a whole number. That would be a rational number. Also, pi would go in here. And finally, a number that is not an irrational number. Well, that's everything on the other side of our chart, which could be a whole number or a natural number, anything that can be written as a fraction. Okay, and negative numbers, those are all options. All right, even repeating decimals, okay, because we know how to write those as fractions, so they're rational, not irrational. Okay, trying to go quick. So on this one, we square root both sides. I saw a bunch of mistakes here that you put one answer and not two. Right, because when we square root both sides, that cancels. You get x equals 30, but you also have to realize that another number would work as well, which is -30. All right, so you had to have both of those answers because -30 times -30 equals positive 900, sorry. A negative times a negative equals positive. Whew! Name all the sets to which this belongs to. Now remember, square root of 36 would be a whole number because it equals 6. But this 35 is not one of our perfect squares, so that is going to give you one of those weird long decimals that doesn't terminate and doesn't repeat. So this is an irrational number. 8/11. Well, it can't be an integer because integers can't have decimals. It's not irrational because irrational means it can't be written as a fraction, and it's obviously written as a fraction. Rational, it's a fraction. Ratio, rational, written as a fraction. Integer, we already said it's not an integer, so it can't be these guys. All right, this one could be a little tricky, but it has a decimal, so it automatically can't be whole, and it can't be an integer, so those two are out. All right, you might think it's irrational because it's like, whoa, that's a weird decimal, but it repeats. Remember, irrational says no repeating, no terminating. So we know that we can turn 5 3/10 repeating. We can turn that into a fraction by just going like this. Remember, put the number of repeating decimals over that many nines. Only one repeats. So we wrote it as a fraction, right? We wrote it as a fraction, so it is rational. We are almost to the end. Woohoo! Okay, let's take the square root of these. All right. These are going to be pretty close. So I'm going to say, hey, Google. Google doesn't work when I'm taking a video. Bummer. All right, I'll do it on the computer. Square root of 8. Boom. Gets me 2.828. Remember how we do this? We line it up vertically, and then I put them in the same form. And in this case, it's easier to do decimal-wise. 2.828. I don't need that many decimals because I already see match, don't match. So that is greater because the 8 is greater than the 7. All right, let's try this one. Okay, square root of 9.8 equals, I should put approximately because these weird square roots are going to give us approximations. 3.1111, and let's get that. So I just have to type it in. Square root of 9.8 is 3.1. Uh-oh, they match until the next digit where they don't match, and then it goes on and on and on and on and on because it's irrational. All right. They match, they don't match. So now I know this one's greater, so I make the alligator eating that. Yum, yum, yum. All right, line them up. Let's line them up. Okay. Oh, order from least to greatest. Well, I see a negative here and a negative here. So I automatically know those guys are going to be the least ones. All right. But let's line it up and show the work. Right. I'm just going to, never mind, I'll just put them in order. 13, negative 3.5, and 3.5. Okay, I'm going to type it in. Square root of 12 gives me 3.464. But that's negative. Watch out for that. Watch out for that. That's going to be 3.60555. All right, that's negative 3.5, and that's 3.5. Okay, so I like to put the numbers 1 through 4 with 1 being the least, just to help me keep track. All right, so I need to put, let's see, what's my least? So it's in between these two, right? But which one would be further left on the number line? I check the 3's, then I check the next digit. Okay, remember, the greater one is actually further left when it comes to a number line and negatives. So this is going to be a little bit more to the left. So that's going to be the least. That'll make this the second least. Now we have to reverse our thinking. Which one's going to be further right? Well, if we compare the 6 and the 5, that puts this at third place, and then the greatest is that one there, 4. So we need to put the 3.5 in first place. Neither of those have that. Then what's third place looks like the one that we have to be aware of. And we want third place to be this one. All right. Okay, name all the sets to which this real number belongs. Well, if we simplify that, 20 divided by 5 is 4. So that's going to be all the ones we got. It's rational, it's integer, it's whole. So this, it's also natural, but this doesn't have natural for some reason. All right, there it is. We did it. Hopefully that helps, and good luck on the test.